Hi everybody, welcome back. Yep, sorry, I just wanted to double check my microphone was on. Welcome back to day 2 of Unit 2. Today we're going to be talking about multi-step equations, specifically distributing and combining like terms and dealing with that when you're trying to solve an equation. Excuse me, I'm going to cough really quickly. We will also see multi-step equations where variables are on both sides and how to deal with that, but we'll do that next time. So today's just variables on one side and dealing with distributive property and combining like terms to be able to solve it. Okay, so when solving a multi-step equation, our goal, let me make this big actually. Our goal is still to get the variable by itself. Okay, now we just have extra steps, hence the multi-step, compared to the two-step equation. Okay, so steps for solving multi-step equations. This is right now with distributing and combining like terms. So these are the steps you want to take. First, you want to distribute. Okay? And there's two parts to it. You need to distribute anything that you need to deal with on the left side of the equal sign. And then if there's more distribution on the other side of the equal sign, you take care of them. You take care of them separately. So you just do one side at a time. Nothing is going to be crossed over or moved from one side of the equal sign to the other. It's almost like cover up one half of the equation with your hand, and you just simplify that side, and then remove your hand, cover up the other side, and then simplify that side, kind of. Okay? Then we can deal with combining like terms. Again, it's based on the side of the equal sign. Do not combine anything if they're on separate sides of the equal sign. Okay? So you go ahead and combine the like terms that are on the left side of the equal sign. So anything alike there, you can combine. Then you move over to the right side and combine anything that's alike on that side with each other. After you've got all your parentheses done and all your like terms are combined and everything, then it should look like a two-step equation. And you can go ahead and use SADMAG to solve it. Okay? Alrighty, so let's try an example. So here, solve the equation, write your answer in set filler notation. I'm going to write that a lot for almost all of your answers from now on, just to get you guys used to practicing it. Okay, so the first thing we want to do is distribute. So on this side, the left side is only negative 24. So there's nothing to distribute, and there's actually nothing to combine over here either. Now on this side, I have to distribute. I need to distribute that 4 to the negative 6 over here and to the 6a. So I'm going to go ahead and do that. The negative 24 is just going to hang out like it is. Okay? But so 4 and 6a becomes 24a, and 4 and negative 6 become negative 24. So there's no like terms to combine here, so I'm just going to go ahead and leave it alone. There's only one term here, so I can't combine anything. Now it's just a two-step equation I can go ahead and solve. So I use SADMAG. I'm going to undo this minus 24 from the a first by adding 24 to both sides. That way these 24s will cancel out, and these actually cancel out as well. That side becomes 0. Oh, I skipped a step. 0. And over here I have 24a. I'm not done because I still need to isolate a. So I go ahead and divide by 24 on both sides. That will get me a single a on this side. And it just turns out that a equals 0. That is my solution. That's my answer. Okay? So when I have something equal 0, it just means 0 is the only number that works for it. It's still a solution. So I'm going to go ahead and write my set filler notation. I'm going to use S and B for shorthand. And I just go ahead and write it a set of a such that a equals 0. And that's all I have to do. Okay? So you guys are going to go ahead and try this one on your own. It does have that negative in front, which hopefully you guys remember means something invisible. And then we're going to go ahead. So you can pause the video, but then we're going to go ahead and move on. Alright, so let's go ahead and go on to over here. There we go. To the next one. Example 2. Now, this one, so the first thing you're supposed to do is distribute, but there's nothing to distribute on this side, and this is only a single term, so there's no distribution there. The next step is to take care of any combining like terms. Now on this side, 8n and negative 7n are like terms, so I would go ahead and combine them. into 1n. So I now have 1n plus 7, or just n plus 7 equals 12. There's nothing combined over here with the 12, so I'm just going to leave it alone. Now it's just, this is actually a one-step equation, so I just go ahead and get n by itself. I'm going to get rid of this 7 by subtracting 7 from both sides. The 7's will cancel out, leaving me with n equals 5. And remember, I can always check my answer. I wonder if I explained this. I don't know if I explained this. But you can check your answer to see if you're right. So if you take the value that you get, 5, and you plug that back into the original problem in for both ends here, and you simplify that side, and it actually does equal 12, you know you're right. So you can check your work. Okay? And now that I have my answer, and I know it's right and everything, I'm going to go ahead and write it in set builder notation. So it's a set of n such that n equals 5. And you guys are going to try this one on your own, and check your work just by plugging in the answer that you got into the variables right here. And if it simplifies to be to equal to the other side, then you know it's true. And that's the right answer. Okay? Give that a go. Alright, now we're going to put it all together. So we're going to do a problem that has distributing and combining like terms all together. And we write our answer in set builder notation. So, very first thing I need to do is distribute this 8 here to the -3 and to the 7b, -7b, I'm sorry. So I distribute that, so I get 6b minus 56b minus 24 equals -24. Now I can go ahead and combine these like terms that I got right here. 6b and -56b together make -50b. And now I can go ahead and solve using StatMeg. So I'm going to undo the subtraction first by adding 24 to both sides. Again, for some reason, I'm obsessed with the 24s canceling out. So these 24s cancel out, but these also cancel out. So I'm just going to write a 0 here. So I get -50b plus 0 equals 0, which is just -50b equals 0. Now to get b by itself, I'm going to go ahead and divide. Where did I put it? Yeah. Divide both sides by -50. The -50s with the b cancel out, so I'm just left with b. And on the other side, 0 divided by -50 just gives me 0. So again, I get 0 for an answer. So set builder notation, just set a b such that b equals 0. That's all I got to do. And I can double check to make sure I'm right by plugging in 0 for b's here. So 6 times 0, that whole term is just gone because it equals 0. -7 times 0 is 0. So 0 minus 3 is -3. -3 times 8 is -24, which is what the other side is equal to. So I know it's a correct answer. Okay? You guys are going to try this one on your own. And once you're done, we'll go ahead and go back to our next part. Alright, so let's go ahead and move on to the next one, which are another kind of multi-step equation, but these are called proportional equations. And it's because they actually look like proportions. So, just a reminder for everybody, a ratio is just a comparison of two numbers. So, you'll see it written with these little colons, you'll see it written as a fraction, you'll mostly see it written as a fraction with us. Where a proportion is an equation comparing two ratios. So we just set up two ratios equal to each other, and we can use that proportion to find missing pieces if we have to. So, example 4 is proportion, and we can solve for x. Now, some of you guys might remember proportions. You can cross multiply, but in case you don't remember, if I was going to solve for x, I would just go ahead and multiply both sides by 9, just to get x by itself. And then, so I do 9 times 2/3, which can get a little messy, but you can do it in a calculator. You get x equals 6. Another way to do it is cross multiplying. When you have two fractions, or two ratios, you can cross multiply. So what that means is that the number that's diagonal from it across the equal sign, if you multiply those numbers, they equal each other. Okay? So for example, if we had 3/4 equals x over 16, I could just multiply the x and the 4 and multiply the 3 and the 16 together. And that way it's more like a two-step or a one-step equation for us, so we can solve for the missing variable. Okay? So try this one, but try to use cross multiplication to solve it. Okay? So if it helps, do these little like circles. Some of you may have learned it and called them butterflies. I think that's what it was called when I was learning it. But go ahead and try it. And then what you can do is you can check your answer by plugging in whatever you get for n back in here and actually making sure these two are equal. Okay? So let's try another one. What if it's more advanced? So sometimes you'll get ones that it's not just an x in a numerator or denominator. Sometimes it could be an x like a group. Okay? We can still use cross multiplication to solve for x. It's just going to take like a couple more extra steps. So, example 5, to solve this, I'm still going to make my circles. They're just a little wonkier, that's all. So I have 5 times this whole group of x minus 6, and then I have 6 times 10. What that looks like when I do cross multiplication is it's 5 times the entire group. So it looks like distributive property. Okay? So it's really 5 times x minus 6 equals 60. That's the equation I'm going to use to solve for x. So the very first thing I need to do is distribute the x into the negative 6. So I really have 5x minus 30 equals 60. Now it's just a two-step equation. I can go ahead and solve that. So I'm going to add 30 to both sides. I get 5x somewhere. Oh, I put it over here. 5x equals 90. Divide both sides by 5 to get x by itself. We get x equals 18. Okay? So just remember when you're cross multiplying, don't forget that you have to distribute when it's necessary. So you will have to distribute when it's like a group like that. And if you want, like if this had equaled like, oh, I don't know how I'm going to explain this. You can use cross multiplication even when you don't have like a proportion set up, because you can always make something look like a proportion. Just put it over 1. So say we had like 6 over the x minus 6 equals 5. We could put 5 over 1 and then cross multiply. Okay? So that's a little bit easier than trying to deal with it not as a proportion. Okay? So you guys are going to try this one on your own. Write your answer in step filler notation. You can check your answer, just throw whatever you get for B into the calculator and simplify it that way. Or you can do it by hand, that's fine. But yeah, that's all I got for, sorry if you hear buzzing, my phone's going off next to me. But that's all I got for today's video. If you have any questions, please write them down and ask in class. Otherwise, we'll practice this skill more in class. And I will see you next time. Okay? Bye! Oh, I keep saying bye, like I can actually say bye to you. Alright, now I can say bye. Goodbye, everybody.